Following on from video 1, I'll go over the PCB assembly and I'll go through each section as I go to solder each of the components. So sit back and enjoy the assembly of the board, and in the next video we'll go through initial power up and any troubleshooting that has to be done. Enjoy the video. Okay, so as we've just got over the circuitry, what we'll solder on first is we'll go onto the back and solder on the battery holder. Now, unfortunately I forgot to put on there which side the positive goes on, so just be aware, this edge piece here, that's the positive, and where it shows this leg here, that's the positive. So battery holder goes on like so, easy as that. So one thing as well when doing surface mounted electronics, now the nib I've got on mine is a little bit too, let's cool down, is a little bit too blunt. We need a fine tip, so I ordered some fine tips for this, specifically for doing surface mount. So you take it off like so. Well, you basically change it to a fine tip. Now I got two types of fine tip. Now unfortunately one of the ones I purchased is only a little bit more finer, which will probably do the trick, but in this case, because we are doing some fine legs, I'm not going to use this fine tip. I'm going to actually use this one. This comes to almost like a needle point. Now, unfortunately, I would normally use my Dick Smith temp soldering iron, but unfortunately it died a few weeks back. I had to get a new soldering iron, so I got a usual cheapie from eBay. Switch the soldering iron on. Now we want to set the iron to about 345. You don't want it too hot. So I'll just wait for this to heat up and we'll get these legs soldered on. Now I use leaded solder, so 60-40 lead. Sometimes with surface mount Eutectic is probably the better solder to use, but it's not easy to be able to find these days. But if you can find Eutectic solder is a much better solder to use. Alright, we are up to temperature. Much solder there, so we'll wick a bit of that away with some solder wick. That's the beauty of surface mount electronics. If you use too much when you're hand soldering, you can always wick it away. Now I will admit, the amount of heat I'm applying here is not a good thing. You have to be careful when doing some soldering with more sensitive components. Have the wider tip when soldering this battery clip on. But everything's all good. It's all nicely soldered, all seated properly. Let's continue on with the assembly of the actual LED flasher. As you can see, we've got the variety of components. What we'll go with first is we'll do the switch. Alrighty, so now, like with every surface mount component, we're most likely going to be needing tweezers. Now, if I've ordered the correct switch component, that should mate up without any issues. There we go. That switch will allow me to turn it wrong footprint. Ordered the wrong switch. Shoot. Alright, I'll have to go to electronics later and hopefully buy a equivalent switch. Alright, so we'll start with the bottom here. R1, C1, C2 and R4. Now they form part of the LED flashing circuit. So let's get these components. So R1 is a 15 ohm resistor, so is R4. There we go. 15 ohm. Really? So what tweezers, you pull back the tape. Flip the resistors on there. So here comes the interesting part. So on one side of the pad, this is R1 and R4 we're dealing with, you apply a bit of solder. Now to make it easier for me, being that I'm right-handed, I'm going to rotate this in the holder because basically, sorry, rephrase that, the other way around. Yeah, no, this way around. So I'll be holding the tweezers in my left hand and the soldering iron in my right hand. So with the tweezers, I grab and align, and then I heat up the solder with the iron and move the chip into the solder, like so. Now normally you would try and get component values showing the same way, but I'm a bit lazy. And then what we do is we come in on the other side with a soldering iron, a little bit of solder, and just touch. Now, hand soldering surface mount isn't as neat as using a reflow oven or a reflow board heater, but it means basically you can assemble your own boards. So just like so. Easy like that. One lot of components down, many to go. So we'll do those caps next, C1 and C2. So a 2.2 microfarad and a 10 microfarad capacitor. Now one thing as well, when you get stuff like this, pays to put it back in the bags they came in, otherwise you will actually forget what the components are. So these are 15 ohm resistors, so I'll put them back in their bag. So this is the 2.2 ohm microfarad cap. Now in this case I won't have too many issues because this one is physically a different size to the 10 microfarad, but normally you don't get that luxury. Now the caps are going to be fairly easy to solder up when it comes to them, and the LEDs. Where it's going to get difficult is with the transistors. I'm dealing with smaller legs, but with the fine tip soldering on it should be relatively easy to solder. Now with a lot of these projects I have chosen the bigger size in the SMD because they're much easier to hand solder than what the smaller stuff is. So, same as before. Little bit of solder on the pad. And with your tweezers, bring your soldering iron up. Up the solder. Probably need a little bit more solder on the pad. Yeah, it's been a few years since I've done hand soldering of stuff. And solder the other side. Alright, I'm going to basically bug out for the moment. I'm going to finish soldering up this board and then I'll see you in the next one. Now I might show some highlights of some of the components, so I might show a bit how we do the transistors, and also with a very tightly packed board like this, you can see some of the ways of how I solder basically in the next montage. See you after the complete soldering up. There won't be a switch on, I've got to go and pick up one. thing with these LEDs. Along there is an arrow that points towards the cathode, and then obviously it goes in that way up. You see this bar here? That's the direction the arrow's got to point. So again with this LED, arrow's that way, so I have to turn it around that way. Alrighty, so we've got most of the main components soldered in for the LED flasher, except for the battery saving circuit, or the soft on off. But we have two transistors to put in. These two transistors are BC848. The through-hole component version would be a BC548. This is what allows the circuit to effectively flash. So let me show you how we will go about soldering in these transistors. Now, as components get on the board, it starts to become more difficult to solder stuff. Generally speaking, you try to solder the bigger stuff. You try to solder the smaller stuff first, and then generally go on to the bigger stuff. But I'm also showing that sometimes it pays to go from left to right, or vice versa, to be able to get components in. So I'm going to rotate this board around, so I can get to these single legs here first. Those single legs are the leg we're going to hand solder with the tweezers, and then the others we'll solder by with it already on the board. So there's a process to soldering things on. These were some transistors I bought for another project, but they're the same style and same type. Come on, out you come. There we go. Do not handle components like this. Not a good thing to, not a good practice. Okay. So here it becomes a bit more challenging. Just gotta get some solder onto these pads here. Like so. Go for this one. Clean my iron. Do as before, I will move that single leg into the solder. So get your soldering iron ready, put the sides of the transistor, melt the solder. Don't get stuck on the iron. Just a second. It has been a while since I've soldered transistors. You've got to learn to be good with both hands, that's for sure. And there you go, there's one transistor in place. solder. Have I got it the right way up? Yes, I do. Not sufficient solder on the pad. I'll put a touch more on there. One thing about SMD soldering is you've got to have a lot of patience. Man, especially when that happens. Excuse me. I need your hand position. Okay, let's try this again. So there we go. Now, once this is all soldered, if I hadn't soldered the battery clasp on the back, I could have used my board heater. What that would have done, it would have heated up the board, got everything to flow again. Now, with the battery clasp on there, I can't do that. Alright, there it's all done. Now I do need to go and get the tack switch, but I'm now going to show you how using hot air I can actually clean this board up. And then of course I'll do another one where I'll show you using the board heater, and that's if you have them. But this is more or less to show you can hand solder simple circuits like this. So I just got to wait for this to heat up. And then slowly but gently heat the board up, heat the board and components nearby up. And you'll see things will start to move. Now, the reason it doesn't blow away is because surface tension helps hold everything in place. Sometimes having flux handy helps as well. See? So there has gone molten. Chip resistor is straightened up. Same with that one. See? Surface tension's pulling them straight. Yep, that one's kind of straightened up. There we go. Put some heat over the transistor legs. As you can see. A little bit of hot air, things straighten up. The reason I don't go any bigger than 1206 is because you can still heat the entire component and its solder joints with a hot air workstation. Get everything nicely soldered. There we go. Well, that transistor needs a little help. Not perfect, but then again it is hand soldered. But it shows just finishing it with a little bit of hot air works a treat. You'll also notice that there are a few joints that have a bit too much solder. That can have tendency with hand soldering, but like I said before, solder wick is your friend, like so. Soaks up that excess solder like that. There. Now be careful after using the hot air, water will be very hot. So there we go, that's the circuit all soldered. Now I'm going to pop this into the cleaner, and I've got to go down to the supplier and get a switch to go there. I'll see you then.
A few moments later.
Okay, so I'm now back. I've got the tack switch, and let's get it soldered on. So these were the tack switches I actually designed it for, and of course I forgot to order the same ones off of element 14, so you can see it goes just there. So I'll put that to one side for the moment. Let's get some solder in one of those eggs. Just gotta wait for the soldering iron to come back up to temperature. Get some solder on that leg there. Switch it on. And heat it up. And there we go. The tack switch has been soldered on. So, grab the battery. Okay. Time to drop the battery in. Alright. Now, when I push that button, that's supposed to be working. Alright, something's not right. In the next video, we'll go over me doing all the troubleshooting, finding out why the LEDs didn't turn on just then. As you know, if you've watched the full video, I soldered the LEDs in the wrong way as per the titles on the screen. We go over my testing, and then I have to go through and desolder the LEDs, ended up damaging them in the process, so I had spares. But in the next video we'll go through all that and see it flash away. And also there should be a follow-up short for the next video, as there was a little change made to the board where I changed capacitor values to slow down the flashing rate. Anyway, I'll see you in the next one. Please like, share and subscribe, and also be awesome and sign up to my Patreon. See you in the next one.